Have you ever looked up at the night sky? I mean, really looked. Far away from the bright lights of our cities, the heavens open up. You can see a river of stars, the Milky Way, stretching across the darkness. It's a sight that connects us to something vast and ancient. For thousands of years, humans have stood under this same celestial canopy. We have felt a mix of awe and curiosity. We have asked the biggest questions imaginable. Where did all of this come from? How did it all begin? And perhaps the most profound question of all, how will it end? Or does it end at all? These questions are not just for scientists in labs. They belong to all of us. They are part of what makes us human. This feeling of wonder is a powerful force. It drives us to explore, to learn, and to seek answers. Think about the first person who looked at a star and wondered if it was another sun. Think about the most fundamental rhythm of life on Earth, the day. The sun rises in the east, travels across the sky, and sets in the west, only to return again the next morning. The moon went through its phases, disappearing from the sky only to be reborn as a sliver of light and grow full once more. The seasons followed one another in a reliable, repeating sequence. Spring brought new life, which flourished in summer, faded in autumn, and slept through winter, waiting for the cycle to begin anew. In ancient Egypt, the god Ra was believed to sail his boat across the sky each day, bringing light to the world. The Maya and the Aztecs created complex calendars based on meticulous astronomical observations. They didn't just track days and years, they tracked vast epochs of time. In Hindu cosmology, the universe is dreamed into existence by the god Vishnu. A kalpa is a day of Brahma, the creator god, and it lasts for 4.32 billion years. In the 1920s, astronomers like Edwin Hubble made a startling discovery. They observed that distant galaxies are all moving away from us. This observation meant only one thing: the universe is expanding. If you rewind the clock on this expansion, everything in the cosmos must have been closer together in the past. If you go back far enough, about 13.8 billion years, everything must have been packed into an incredibly hot, dense point. This was the beginning. One of the most important pieces of evidence is something called the cosmic microwave background, or CMB. The theory predicted that if the universe began in a hot, dense fireball, there should be a faint afterglow of that heat left over, filling all of space. Then, in 1965, two American radio astronomers, Arno Penzias and Robert Wilson, stumbled upon it by accident. Another powerful piece of evidence comes from the abundance of the lightest elements in the universe. The Big Bang Theory makes very precise predictions about how much of each element should have been created in this early phase. Despite its incredible successes, the Big Bang Theory is not complete. As we rewind the cosmic clock towards time zero, the equations of Albert Einstein's theory of general relativity start to produce nonsensical answers. At the very beginning, the theory predicts a point of infinite density and infinite temperature, all packed into a point of zero volume. Physicists call this a singularity. It represents a wall, an edge to our knowledge beyond which we cannot see. The Big Bang Theory tells us what happened after the initial moment, but it cannot tell us what the Big Bang was, what caused it, or what, if anything, came before it. The standard Big Bang model leaves us at a cliff edge, staring into the abyss of the singularity. But what if that cliff isn't an end, but a turning point? This is the core idea behind one of the most compelling alternatives to a single beginning universe, the Big Bounce. In this scenario, our universe is like a cosmic lung, eternally breathing in and out. The Big Bang was not the moment of creation, but simply the moment our particular cycle began. For the universe to avoid the singularity and rebound, we need a new theory that works where Einstein's general relativity fails. We need a theory of quantum gravity. Loop quantum gravity proposes that space itself is made of discrete, indivisible atoms of space-time. When the density reaches a critical maximum level, gravity actually becomes repulsive. The theory replaces the problematic singularity of the Big Bang with a quantum bridge that connects a previous contracting universe to our own expanding one. Another fascinating cyclical model comes from the world of string theory. This idea, known as the ekpyrotic model, proposes that our universe is a three-dimensional brain floating in a higher dimensional space. The Big Bang, in this view, was not a singularity, but the cataclysmic impact of our brain with its neighbor. The incredible kinetic energy of this collision was converted into the matter and radiation that filled our universe. This process repeats endlessly, with each collision wiping the slate clean and resetting the cosmos. It's a powerful vision of creation through destruction, happening over and over again on a cosmic timescale. In the late 1990s, astronomers made a discovery that completely changed our understanding of the universe's fate. Two independent teams of scientists were studying distant supernovae to measure how fast the universe's expansion was slowing down. But they found the exact opposite. The expansion of the universe is not slowing down at all. In fact, it is accelerating. Some mysterious force is pushing everything apart, faster and faster. We call this mysterious force dark energy. Dark energy appears to be a property of space itself. As space expands, more space is created, and with it, more dark energy. This creates a runaway effect, an anti-gravitational push that is becoming the dominant force in the cosmos. For cyclical models like the Big Bounce, which rely on a future collapse, dark energy presents a serious, perhaps fatal problem. If this accelerated expansion continues forever, then the universe will never recollapse. The cosmic lung will only ever exhale, never to breathe in again. This has led some physicists to believe that cyclical models are simply not viable. So how can we decide between these two competing visions of the cosmos? The answer, as always in science, lies in observation and evidence. Cosmologists are actively searching for clues, reading the cosmic tea leaves left over from the universe's earliest moments. They are looking for subtle fingerprints that could distinguish a simple Big Bang from a more complex cyclical origin. Another crucial piece of the puzzle is gravitational waves. These are ripples in the fabric of space-time itself, created by the most violent cosmic events. The coming decades promise to be a golden age for cosmology. New observatories, both on the ground and in space, will soon give us an unprecedented view of the universe. Each new stream of data will bring us closer to answering whether our universe is a singular event or one of an infinite series. The final theory of everything, if one exists, may be stranger and more beautiful than anything we can currently conceive. The question of the universe's ultimate fate is not just a scientific one, it carries profound philosophical weight. The implications of these cosmic models ripple outwards, touching upon our understanding of meaning, purpose, and our own existence. A linear universe presents a stark reality. It suggests that everything we know is ultimately temporary, destined to be erased without a trace. A cyclical or eternal universe offers a completely different perspective. If the cosmos is reborn again and again, it suggests a kind of cosmic immortality. Nothing is ever truly lost. It is just transformed and recycled in the next great cycle. The universe is not something separate from us. We are made of star stuff, as Carl Sagan famously said. We are the means by which the cosmos gains consciousness of itself. Our questions are the universe's questions. By seeking to understand the cosmos, we are fulfilling a deep and ancient purpose. We are completing a circle, connecting our own brief existence back to the vast and possibly eternal reality from which we emerged. I invite you to keep looking up. I invite you to stay curious. Read, watch, and learn about the incredible discoveries being made every day. The universe is the greatest mystery story ever told, and we all have a front row seat. So does the universe end? We do not yet know the answer, but the quest for the answer is in itself a beautiful and noble endeavor. The story is not over. Go out and be part of it.